Thank you. I am really happy to be here. I'm talking about diagnosing models and code in R. So long-running models, big data stuff. Of the questions that I get as a help desk R expert, this is one big category: is why isn't my code running? Why is it taking so long? What can I do? Help! I was running a model for 2 days and then it got killed by VINCI. What can I do? So this is going to be a discussion about how I would go about diagnosing a model. I don't claim to know everything, and I certainly won't be going over everything in here. This is kind of where R, statistics, and a little bit of the artistry of statistics intersects. So data science is somewhat science, and there's somewhat of an art to it. And this is where we're going to be talking about some of the artistry that goes beyond just the raw statistics. What we think happens theoretically doesn't necessarily happen when we put code into the program. So a couple of notes about my code. If you are not familiar with tidyverse, I apologize. You should familiar yourself with tidyverse. My code is almost always in tidyverse style, which means that I am assuming that you have dplyr installed, which is for all of the data manipulations, filter, selecting variables, manipulations, such as mutate or transmute, for MapReduce operations, and McGritter for the pipe. If you're not familiar with the pipe is a simple convention that says pass the result of the left-hand side into the right-hand side. So pass this into that. And so it makes it so that your code is more readable and you can chain operations together in a way that is much more human readable than endlessly nested parentheses. If you haven't familiarize yourself with tidyverse, I highly recommend that. Other than that, if there are other packages that I am using that are not typically loaded with tidyverse, I will try to use the double-colon scoping operator to indicate that I am using a function from a specific package. Okay, so let's start out with a quick question. I'd like to know what your experience is with R. So I need to know, are you an expert and you could be giving this presentation yourself, or are you a practitioner, which would mean R is what you usually use for your analysis. You're comfortable with most functions of R, but would not consider yourself an expert. A journeyman of comfortable with most things in R, but so maybe you use R and SAS or SAS and Stata or R and Stata, or are you kind of just getting your feet wet with R and you kind of know a couple things, maybe you know how to do graphics, but you're not really comfortable with much of the other stuff, or are you a complete noob, to use gamer language, and you don't, and you know basically what R is, but know nothing more beyond that?
All right, well, that poll has been open since you introduced it, and answers are streaming in. It looks like things are leveling off, so I'm just going to give people just a few more seconds before I close the poll.
Okay. While people are finishing their answers, I will go over an example. This is a recent project that I have been working on, and so it's kind of a work in progress, but it was instructive to go through because there were a lot of things that I found that will be helpful for people to see how, and it is a real world example of a big model that is complicated, that has issues with it. So we are looking at choice data from, or data from the Choice Act and how veterans choose different hospitals. And we're specifically looking in this model as modeling death after discharge from hospitals. We have a little over 1 million records with recorded almost 22,000 deaths. We're trying to fit this with a generalized linear mixed effects model. So we have random effects, we have fixed effects. It's complicated. We have to fit it with restricted maximum likelihood. So there's going to be iterations. So it's going to take a long time. Okay, so results are?
Yes, there's only 5% said that they are experts. 32%, which is the largest number, excuse me, consider themselves practitioners. 16% consider themselves journeymen. 27% consider themselves learners. And 16% consider themselves noobs.
Okay. All right. So I think I've got a good crowd here. Hopefully, what I can present is going to be useful for people. There are some things that I will mention that I won't actually show. But I would encourage you to go and look at those topics if you are not familiar with them, especially for the learner group there, because there are some very useful things that I will mention, but I don't have time to cover in this presentation. So let's go to a second poll. This is the last poll, so I'm not going to just be doing polls every other slide. But I would like to know what a typical data set is to you. In the VA, we have wonderful, especially in VINCI, we have access to enormous amounts of data. And so we could be doing billions of records. I'd like to know what kind of sample size or what kind of a data set is a typical sample size for you. Tens, hundreds, thousands, tens of thousands. I typically work in the millions. Hundreds of thousands to the millions is most of what the work I do for actual studies is. But I have done everything from single digits all the way through. I don't think I've ever done billions, but hopefully someday I will get a data set that large that I can analyze, and that will pose some interesting challenges other than the things that I will go over today. Most of what I will be doing today will be millions or below, probably in the tens of thousands or hundreds of thousands is where we will mostly be spending our time. So do we have?
I just closed the poll, and I can read the results off if you'd like.
Yes.
Nobody answered A, less than 10. Only 5% answered B, tens. 16% answered C for thousands. Another 16% answered D for tens of thousands. 21% answered E for hundreds of thousands. 24% millions, and 0 for billions and more. So it's pretty steady across tens of thousands, hundreds, and millions.
So it looks like we've got a good crowd here. So mostly between tens of thousands and millions. So that's exactly the crowd that this kind of presentation is geared for. So that's good. Okay. So the first thing, when you are asking the question of why is my code running so long, the first question is, I want to know how long it takes. The simplest answer is to use system.time function. And what this simply does is it takes a time measurement and runs the code, does another time measurement, takes the difference between those two, and gives you the answer. This is the kind of code that we're going to be running. So we're saving we're saving the system time results to runtime. And inside of that call, there's the model fit. When we're taking our data, I am sampling it down to 100,000 to make that a reasonable amount. So we know that a million is going to take like longer than we have. So we want to sample it down to something that is reasonable. Now in statistics, it makes sense. If you're going to sample a population, the results should generalize to the whole population from the sample to the whole population. Same thing here, is we are running a model, and if there are problems with the model in the sample of 100,000, then there's going to be problems in the model with a million. So don't think that you have to always look at your whole data set. Sampling down and to reasonable bite-sized chunks is totally reasonable and appropriate to do. We are doing Glimmer. This is usually pronounced Glimmer, G-L-M-E-R, Generalized Linear Mixed Effects Random Model. I am not showing you the formula because it's long, but there are several variables in it. So what comes out when you use system time? You have a user, a system, and an elapsed time. The first variable, the first column in that is the user time. This is how much time the actual computations took. System time is the time of system operations such as disk input, output, memory, swaps, that kind of stuff. And then elapsed time is the total clock time, the wall time that it should have taken. That doesn't always reflect the actual wall time if there's process swapping and stuff. But essentially, if you're running it on your computer, that's how long it passed on the wall. There are two other values on here that are not present, and they're not usually shown, but they will be shown if, for some reason, you are using a function that will spawn child processes, so parallel processes and stuff like that can be counted in the system time, and so you would see numbers in there. But for simple sequential operations, which is what we normally run in R, you're going to see just these three numbers. I will talk a little bit about parallel processing in the end because that's one of the ways that we get around this kind of long code operation. So, excuse me. I have to take a drink, sorry. So a useful trick for this is actually to use the lubridate package. And so I'm taking runtime, I'm dropping the class of proc time off of it, and then I'm saying this is actually a duration in seconds. And what I get out is the number, an easy conversion to hours, minutes, seconds, or whatever. And so we see that we're having 31 minutes of the 4 hours is in memory. That's a little bit concerning. If you have a lot of system input output, such things as, then you're doing something like you are writing to disk all the time, or you're reading from disk all the time, or you're writing or reading repeatedly to a database. Those are the kind of things that can really kill a project, really kill runtime. Another thing to do is memory, if there's a lot of memory allocation, you'll see that system time just explode. And if you're taking a lot of system time, you're doing something wrong. It should be all on the execution time. This looks fairly reasonable. I'm a little concerned about the system time, but not overly concerned. There's a better way to get what your program is doing, and that is profiling. And I find that a lot of people, even those who consider themselves R experts, don't realize about profiling. The other things that would be great to use are debugging and traceback functions. Especially when you have code that is throwing errors, you want to use that debug function and or trace functions, or the trace functions where you can inject code into a function to get some useful information. That's beyond the scope of what I'm going to cover today. I think that profiling is totally underrated and is useful both for modeling, figuring out why any code is running. So it's useful for figuring out why any code runs this long, not just necessarily models, but it will give us a little bit of insight into models. But this is kind of one of my first things to check to say, okay, is this doing what I think it's supposed to be doing? So if you are running RStudio, which if you are not running R through RStudio, I may question your sanity, but that's between you and R. There are some R purists, which I won't resent, but I highly recommend using RStudio. RStudio is on VINCI. There is a menu specifically for profiling. You'll go to Profile, and you'll go to either Start Profiling or Profile Selected Lines. This is my go-to, is Profile with Selected Lines. You highlight a section of code, usually the code that's actually giving you problems, and you say, profile this. Now, what profiling does is it runs code. You know it's running when you see in the console this clock icon next to the interrupt or the stop button or the stop profiling button. And you'll know that it's running. You'll let it run for a while. In this case, I let it run for like 4 hours and got the results. Once it's done, it will display a report. Now, this report is, what it's doing in the background is every like 2/100ths of a second, it's taking a snapshot of the code and saying, where is this code? What functions is it running? What's the stack? So what function called which function, which called which function, those kind of things. Then you get a report. The first page of that report is called a flame graph. The flame graph shows the function calls as horizontal bars. So the first thing that we called is system time. Then we are in a pipe, and then we are in Glimmer. So that's what we're actually wanting to pay attention to, is everything that's above Glimmer. So the first calls are on the bottom, and the deeper you go, the higher up you get. And the width of the bar is the time that was spent in that function. So we see Glimmer calls optimize Glimmer, calls optrap, calls derivative 12, which calls some anonymous function that then does a whole bunch of stuff inside of that. We can't, or we probably shouldn't be messing with anything that comes in from the optimize, anything below Glimmer. We shouldn't really be messing with, but it's good to know what's happening. And we're spending a lot of time here in computing those derivatives, which gives me information as a statistician to know where I should be looking to figure out problems in the model. Problems in the model will come from deficiencies in the model, correlations in the variables, or boundary problems where it's estimating right next to a boundary of 0 or something like that. The next page is the data table. So you'll see two tabs. One will be the flame graph, one will be the data table. The data table takes that flame graph and summarizes it across all of them. And you'll see how much time was spent in each of those functions and how much memory was used for those functions. When you're coming into memory problems, this is what you want to look at. If you're coming into execution time, you'll see, you'll want to pay attention to the time column. You can see that there's some pulling functions or some functions that are nested inside a list that are doing some work here. But this function, evaluating this function repeatedly is where we are getting stuck. So if we can optimize that, or optimize how to get the derivative, it'll be better. So in this case, we get a degenerate Hessian or a not full rank there, which means there are extraneous variables in the formula. This can happen when you have variables that are essentially the same or giving the same information and it's been presented in different ways. So like if you included a variable and a transformed version of that variable, so like you rescaled that variable, those would be considered redundancies in the matrix. To check this, let's look at a couple problems. So we're just going to take our model fit, pull out the model frame, which is the data that was actually used to fit the model, and summarize that. There's a lot of other variables that are listed here that I have abbreviated to show a couple of problem cases. So one of the things that we have in here is a station ID, STA6A. We also have in here an ED indicator where almost all of them have ED departments. We have bed count, we have academic affiliation, where almost all of them are academically affiliated. We have rurality that is almost never true. So these are some problems that have some sparsity issues, particularly ED and academic affiliation are going to be identifiable from the station ID. And so these are actually problems that create redundancies in our matrix that are giving us problems fitting the data. One thing I like to do is I like to look at the correlation matrix. I examine the correlation matrix, reveal where there are deficiencies. So highly correlated variables should be of concern. This is one way I do it. I take the model fit, pull out the model matrix, which is that model frame that has been converted into a matrix of ones and zeros. So all the factor variables have been separated out into individual columns. Then I'm just looking at the correlation, throwing up an image of that. So the darker places are going to be higher, lighter places are going to be lower. This diagonal line is is the diagonal of the matrix, and I'm only showing part of it to show some of these. We only are worried about one side of the matrix or the other. And we can see there's a couple of problem variables here that are very highly correlated. I pointed them out with the purple arrows. So I want to actually enumerate what those highest correlations are. There's not a really great way to do this. There's a lot of different ways to do it. None of them are really, there's nothing really built in, but this is the way that I do it. So I just take the correlation matrix, convert it to a data frame. Then I reshape it. So I pivot it longer, and then I just filter out the ones that I don't want to see. I don't want duplicates, and then I arrange it by the descending values. We can see that our rurality variable is highly correlated with our drive time. So this is drive time from a patient's address to the facility that they visited. The race and ethnicity, those are highly correlated, which should be concerning. The age and our Van Raven Elix Hauser score are highly correlated, which we kind of expect. And these things. So these are some of the concerns. So what we're going to do, another way to look at this is variance inflation factors. And this is something that many people may not be familiar with. Is a variance inflation factor is a way to measure if a variable, if there's correlation in the design matrix of a model, then the variance of the estimates in that model could be really, really high. And the way to measure this is to look at the generalized variance inflation factor and then divide by, or raise it to the power of 1 over the 2 times the degrees of freedom. The bigger that number, the bigger concern that we have. Here we see that our emergency department estimation, which we've already said is redundant in the matrix is causing a lot of problems. Yes, and that is a ridiculously high number. Anything really over like 4 or 5 as a rule of thumb is bad in this inflation factor. So both of these, ED and bed count, are problematic. And the reason they're problematic, as we already discovered, was that we've included station that identifies those variables. Okay, so the reason that, let me back up here. The reason that these cause problems when we're fitting, especially when we're doing something like a generalized linear mixed effects model, is that when you have multiple parameters that represent the same thing, you can just you can raise one and shrink the other, or shrink one and raise the other, and then you can just transfer between those variables, and you end up never converging the model. That's one of the reasons why you're worried about correlation, is because there are just trade-offs that you keep bouncing back and forth between, and the model never converges because you keep changing more than you should be. But what it looks like in the geographic spaces, you're just sitting on a line or a plane that's on top of a plateau of maximum likelihood, and you're just moving around in that plane, and you don't ever settle on a position because they're all equally the same. Okay, one other problem, and this may be specific to R. I'm not sure. I know that some machine learning tools will automatically handle this, and that is to standardize variables. Fitting algorithms, particularly the one with generalized linear models, does not automatically standardize variables, and it does not like that. It does not like variables that are orders of magnitude different than each other, because when they compute that correlation matrix and compute the eigenvalues, one is just going to be enormous. Typically, it will actually let you know this if it comes in across a situation like that and say that you should standardize the variables. But it's a good idea to do it anyway. So one of the things that we're going to fix is we're going to fix our age. Age, we're going to standardize it from a scale from like 20 to like 90 to a scale of 0 to 1. So, and to show the difference that this makes is just a model with age and a intercept drops from 83 seconds down to 15 seconds to converge, with everything else being the same. Just by changing the scale of that variable, the model was able to converge much better. Now, I know that it's coming in the future that you will be able to automatically standardize your variables, or that will be an option in the controls. As of right now, that's not implemented in the version that is on VINCI. I don't know if it's been fixed on CRAN, but it is a good idea to standardize your variables beforehand. Other things that you may want to do. Other transformations. Some of the other transformations that I performed in fitting this model that I didn't show in the slides. I took some log transforms. So I took a variable that was from like 0 to 300, and it scaled it down to like 0 to 6. And I took some percentages that were 1 to 100 and scaled those down to between 0 and 1. And those all help the fitting algorithm work better. Okay, so another thing that a lot of people aren't familiar with is marginal model plots. This actually comes from the CAR model, and I apologize, this is PowerPoint. The CAR in that CAR : MMPS should not be capitalized. It's categorical and applied regression. package. The idea here is that in a marginal model plot, there are two lines. One's a smooth estimated directly from the data, the other a smooth estimated from the fitted values. If the model is specified correctly, the two lines should be very close. In this case, they're really not. We can say that there is some level of misclassification here. And I think that this is likely because of a log transform, which is what I did to fix this variable. And so we see that it's a heavy tailed. If we log transform it, it can fix this. So we've kind of gone now from long running models to diagnosing, like, why is my model misfit? And misspecifications in a model will also make it take longer. I mean, if you've got the right model, it'll just go right to it. Okay, so summarizing up what we have discussed. The first thing that I didn't really mention, but I think should be discussed, or at least thought out, is evaluate if it's worthwhile. Your time as a person, as a researcher in the VA, is expensive. Computational time is cheap. If you've got time to wait, oftentimes waiting is a decent solution. So first thing, evaluate if it's worthwhile. Spending a week of work to say that spending a week of work to save a few hours of computation time is very rarely worthwhile. With that caveat, if you've got to figure out what the problem is, so say it's not converging, figure out why. Is it spending too much time in the memory? Is it spending too much time extracting things from the data set? So run a profiling file to figure out what's going on. And that works with all code, not just models. Use traceback, use debug, figure out where the errors are coming from. Another helpful tool is to sequentially add or delete variables from a model, specifically for the runtime, because there are usually specific variables that are causing problems with your model. Figure out if the model is correct, or if adjustments such as transformations, such as scaling variables, will improve the runtime or the fit. Then if all else fails, then you throw more money at it. One thing that I do not cover, but I think that I should cover here, is that in R on VINCI, well, not in R, but in VINCI, we have access to the SAS grid, and SAS can itself run R code. So one of the ways that people can avoid getting through the issues of jobs being killed and shut down is to run your code in batch on the SAS grid. If you need instructions for that, there are instructions on Vincipedia. I am not an expert on that portion of it. Mark Ezzo, who is the SAS expert for VINCI, is far more familiar with running things on the SAS grid. So I won't cover his area of expertise, but let people know that that is one of the possibilities of being able to run longer running code, is to run it through SAS so that it goes onto the SAS grid. So you're on a separate machine than what is usually running our code, and that will allow you to run longer jobs or run it in a dedicated space. So that being said, even on the SAS grid, you may want to run things in parallel. So either maybe you're running multiple models, or you are running multiple models on subsets of data. There are two big paradigms for parallelism in R. Yeah, let me go. We'll go through this and then I'll answer questions if there are any questions. If you have questions though, please put them in the Q&A. I'm happy to answer questions. So just a shout out. I'm going to talk about a little bit about parallelism, and then we will go to questions. So parallel. So by throwing more money, I mean computational resources. The two major approaches are for each, which is an explicit parallelism, and then there is a new approach that's actually a couple years old now, but it's called futures, which is an implicit parallelization. So let's talk about for each. So for each, you have to set up a cluster of workers. This doesn't work very well in VINCI because we have two servers, and that doesn't, you're not setting up a whole network of things. But what you can do with for each on VINCI is to spawn multiple R processes. And then you have special functions that will delegate computing each iteration of a function or of a loop on each of the different nodes or different processes. The main package that you're going to want to look at for this is for each. It was made by Revolution Analytics before that was bought by Microsoft. But the newer approach is Future or Futures, which is supported by our studio and their development. This is a different way of thinking about parallelism. Basically, it is achieved through registering a plan or a strategy. And this really works well because you can set multiple levels. Again, here, this is not totally applicable to VINCI, but I hope to get some things working with like the SAS grid and stuff that maybe will improve this. Sequential would be a strategy that is the default. So you're just running things one after another after another. Transparent, I'm not sure how that differs from sequential, but it is for some reason. Multi-session is multiple R sessions on the host computer. This is what works typically with Windows, or and as such will work on VINCI. Multi-session, multi-core is for R processes. It will not work on Windows, but should work on SAS grid because I understand the SAS grid is Unix-based. Or if you have a development machine on VINCI that has Linux, but Linux or Unix on it, that would run. Multi-process is kind of the default if you're wanting to run things in parallel. Basically, it says multi-core if you can do multi-core. If not, do multi-session. So that will work whether you're on Windows or Unix or whatever, and it'll kind of choose the best case scenario. Cluster is a heterogeneous cluster of machines. So what would be traditionally called a Beowulf cluster. So you can have a bunch of machines. One really nice thing here is that that remote is one way to say, I have code on this machine, I want to run it on that machine, which will be helpful outside of VINCI. You're going to want to run everything on VINCI inside of the server or your development machine or on SAS grid, the node that's assigned to that process. So I am happy to take questions. There are more topics here. And so this was a really quick overview of how I might go about diagnosing a model. There is a lot more to look at. Basically, you're looking for inefficiencies. And those inefficiencies can pop up from some pretty weird places. This is some of the weirder places that they pop up from. There is one question in the Q&A, but it looks like they have answered it themselves, but I'll go ahead and repeat it. Is there anything special about 4-H compared to MCL Apply? I've used MCL Apply often in my previous work. Perhaps it doesn't work in VINCI. I'm not super familiar with MCL Apply. I believe that MCL Apply is a much older version than 4-H or Fortunes. Are there tutorials for using 4-H features, VINCI, RStudio, and/or R on the SAS grid? That is a very good question. So for the first two, 4-H features on VINCI with RStudio, not yet. They are coming though. I am working on a project called R Academy. Because COVID was what it was, this has been delayed, but we are getting things going again. And that is one of the advanced topics that is on the syllabus that we will be preparing some tutorials for VINCI that you will be able to find on Vincipedia. Or on SAS Grid. Yes, there is a tutorial for that. You can find it on Vincipedia. You can find it, it is in the SAS portion of Vincipedia. I do not have the link handy for that. Okay, let's talk about the next question. Any tips on reading a data file, example, a SAS file, into R that is larger than memory? SAS files are not friendly to R, to say the least. They're SAS files. SAS does not like people playing with their stuff. So R can read SAS files, but it must read those files into memory. What I would recommend, if you have large data files that is larger than memory, is leveraging the databases that are on R. Very rarely will you actually have a data set that can't fit in memory that you're going to be working with on R. And that is, if you're needing out of memory computations for R, that's out of the scope of what I'm talking about today. But I would recommend taking that SAS data file, putting it onto the server, the Microsoft SQL server that is assigned to your project, and then using dplyr and dbplyr to make all of your, to query that data directly from R. So use dbplyr to create a pointer to the table that you can then filter, that gets filter and do mutations on, that gets translated into SQL, and so that those data management and data manipulation processes happen on the SQL server rather than in R in memory, because the SQL server is built for that kind of problem. To do those kind of operations on data and manage data, filter data, the database servers are great for that. R is good at that, but as far as implementation and speed, you're going to get more leverage by using the databases on VINCI than you would be trying to figure it out in memory, which is just better. It's the right tool for the job. Always use the right tool for the job, is the point. And in that case, the database servers are the right tool. So when you have really big data, database servers are your friend. Is there a tutorial on using dbplyr on VINCI? setting up credential importing and exporting data from to SQL Server. Yes, there is. Actually, the last cyber seminar that I presented goes over many of those details. There will be more detailed tutorials on Vincipedia eventually. Those are coming. I would refer you to my previous cyber seminar where I talk about using databases with R. There is a package that I talk about in detail that is still coming. We are working on getting approvals to put that package into, but there is red tape and COVID gets in the way and things like that. But it is basically you establish a database connection and you point all your tables to there. So R does work very well with the Microsoft SQL servers that are connected to VINCI. It uses the integrated authentication, so there's no passwords or usernames that have to be remembered or put in code, heaven forbid. And then it's when you're using dbplyr, you define all your operations, and when you need to pull down the data, you just say the operation is collect. So collect the data, and it comes down into memory. But a lot of things can be done and are pushed off onto the server. Yeah. So I don't think that I have missed any questions. If there are any others, if you're having issues with any of those connections, I refer you to the help desk where I can help you in a one-on-one basis to connect with your data, to help figure out what's wrong with your model. Sometimes it's just another pair of eyes that you need, and there's that. Well, I'm not sure whose razor it is or whatever, but when you're running your code, it's not going to work. But if I come and look over your shoulder, it's going to work just fine. So sometimes you just need someone to look over your shoulder.
Dr.
Yeah.
Red, you haven't missed any questions, but one person sent something into the chat, and I think it was in reference to you, and the chat only comes to me, in reference to you maybe struggling to find a word or a term, and this person just wrote SAS files in R using Haven. I'm not sure if that's helpful or not.
SAS files in R using Haven. So Haven is the package that is used for reading other statistical languages files. So Haven is the package that you're going to want to use to read SAS files. The question that I was answering was specifically if the file is larger than memory. If you are just reading a SAS file, the Haven function read SAS is fantastic. It also includes functions for SPSS, Stata, the read _DTA, I believe. I think that there are other formats in there. But Haven is the package that you would use for reading foreign language, so other statistical languages data files. You also should look at read Excel to read Excel files, and the read R package that is very nice for reading CSVs, flat files, fixed with format, where it does some nice inferences about what the column types should be.
This person also just sent in or DS read.
I'm not familiar with that one, but I will have to look it up.
One question came in while you were talking about that chat that I alerted you to, and they're asking how to contact the help desk. Is that VINCI at va.gov?
Yep, VINCI at va.gov. It goes to the help desk. If you put R in the like R question in the subject line, it will get filtered to me. I believe automatically. If there is, if you just type it into the question, then someone may read it and then send it on to me. But yeah, VINCI at va.gov is the help desk for VINCI. Questions can go there. If you mention that you're using R, there's a good chance that it will come to me, unless it's not really an R question, like it's a Windows question or something like that, and I may then bounce it off to other people.
Okay, so VINCI at va.gov and put R in the subject line.
Yep.
Well, we don't have any questions currently. It's possible that somebody will come up with one momentarily who's thinking about it now. But in the meantime, do you have any closing comments you'd like to make before we close?
Sure. I love to work with people. I love to work on other problems. I hope that this was helpful for people. Like I said at the beginning, there is an artistry to some of this that sometimes comes with experience, and I don't claim to be the most experienced person in this, but I can certainly help out where I can. And if I haven't covered something that you find helpful when diagnosing problems with models, I would love to hear about it, either through the help desk or just send it to me directly, andrew.red@va.gov. Andrew.red@va.gov. Same as all the typical email addresses. Okay, so there is another question that came in. You said there is an R series that you were teaching. I could register through Vincipedia. That's a great question. It's not actually a course per se, like a lecture series. However, some of the I will record some presentations. This is going to be a series of tutorials of using R on VINCI, and just using R in general. So the first one that should be up shortly is just how to get onto VINCI. What do you deal with when you're dealing with R on VINCI? Just the ins and outs of getting started. Then we'll talk about syntax and things like that that are general to R. Eventually, we will get up some tutorials on things that are VINCI specific, like using databases, using the SQL servers, using R on SAS Grid, which is already on the SAS portion of Vincipedia, but it's we will get a reflected thing for our users on that side as well. But it's all coming. It's going to be great stuff. Just look on the Vincipedia for the R. It's called the R Academy. There is a page up now. It's a single page that has the syllabus of the topics that we are going to go through. And those should get populated, start getting populated like within the week, and probably one or two a week for the next little while.
It looks like there is another question about guesstimating how long a model will take to run before running it. But to the answer to the question about recording, you'll get an email in 2 days.
Okay. Is there a way to guesstimate how long a model will take before running it? Unfortunately, not really. Start small before you scale up to your whole data. I find the best. And you can usually, after a few runs of a couple small sets, you can get an idea of how long it takes with that set of data. Unfortunately, the scale up is not always linear. Hopefully it's less than linear. So adding a whole lot more data doesn't add a whole lot more computation time, but it entirely depends on how that algorithm is working. One thing that I didn't go into detail on, but I should point out, way back up here in our first one. In this Glimmer call, there's a control option. That Glimmer control creates a list of parameters that affect the fit of the model. And you can adjust things such as tolerance, how many iterations you want to allow to go through, or how many, what the different criteria is that you want to do, and adjusting those will affect how it is fit. And sometimes one optimizer will work a lot better than another optimizer. And the details of when one works over another is far beyond the scope of what I wanted to go on to today. But reading the help files, that's one of the first things I teach people. When you learn R, learn to read the help files. If you're not familiar with the help files, read the help files. Learn how to read the help files. Glimmer and LME4 is extensively documented. The team that maintains LME4 is very good, and they've done extensive documentation on those things. So read the help files on those, and adjusting those parameters can make a model converge faster or slower, or you can make sure that it's more precise. You can also do things like specifying the starting parameters, things like that. All of those will affect how well it fits. But the more data you put at it, the longer it's going to take, and unfortunately, there's nothing that we can do that will change that fact. If we could get instant answers with infinitely large data sets, we would be out of jobs. So the more data you throw at it, the longer it's going to take. You can do estimation of how long each iteration will take with different size data sets, and then extrapolate. That's not always necessarily accurate, but it's better than nothing.
Okay, well, we don't have any more questions, and it's just about time to wrap up, and you have made closing comments. So without any further ado, if it's okay with you, I'll go ahead and close the webinar.
All right, thank you, everyone.